Basicity of amine. We have already discussed this. An important topic in that is relative basicity of amine. In the exam, they may usually discuss the relative basicity of amine, or they may also ask the effect of substituent on basicity of amine. So we have already discussed that amines are more basic than ammonia. The simple logic to this is the lone pairs of electron on nitrogen density is more when you have electron donating R group in amine and you don't have R or electron donating group present in ammonia. So that is why amine is more basic than ammonia. That is what we have discussed. In relative basicity of amine, we have also already discussed that the primary amine has some value which is 37 into 10 to the power of minus 5. Secondary amine has 54 into 10 to the power of minus 5. And tertiary amine has value of 6.7 into 10 to the power of minus 5. And we have seen that this value in tertiary is less because of steric hindrance. See, in the exam, as you have already come across, right, in your first exam of HAP, that you will maybe ask for 10 marks question. The right way of representing the particular question, if they ask you, discuss the relative basicity of amine and the effect of substituent on the basicity of amine. Then you should start your answer with the introduction that whatever we have studied from the first page of amine, that what are amines, their differentiation into primary, secondary and tertiary amine, followed by basicity of amine with the reaction where we have written RNH2 plus HCl. H goes here, this lone pairs are utilized for bond formation. We get RNH2 H with a positive charge on nitrogen and Cl minus. Basicity constant we have discussed, that should also be included in that. Where we are talking about Kb, which is equal to concentration of RNH3, which is in ionized form, OH minus divided by RNH2. This we have to include, followed by the relative basicity of amine. The only thing which we haven't discussed in the relative basicity of amine, which we have to represent in our answer, is what happens when electron withdrawing group is there. So the basic simple analogy to that is whenever you have electron withdrawing group attached to amine, it tries to pull electrons towards it, which leads to decrease in the electron density. Thereby this leads to decrease in the Kb value. That means it is reducing the basicity of amine. So this particular reduction in the basicity of amine due to electron withdrawing group can also be included in the topic of relative basicity of amine, which you need to add up and refer to the notes. You can take online sources or your textbook, they will have enough data with the values in it. But only thing you have to represent well and accurately is R group are electron donating in nature. This leads to increase in the electron density of the lone pair of electrons on the nitrogen, and this leads to increase in the basicity. If we have a group which is electron withdrawing in nature, this leads to decrease in the electron density of lone pairs of electron on nitrogen, and this leads to decrease in the basicity of amine. This is what you need to generalize in your statement whenever you are writing. The next thing what we are going to discuss here is qualitative test for amines. We have already discussed qualitative test for carboxylic acid. You can be sure that these kind of questions can be asked for maybe VSAQs or LA SAQs. So in qualitative test, first test I'll tell you is litmus test. In litmus test, amines which are in basic in nature will turn red litmus to blue. Acid will change blue to red. Bases will change red litmus to blue. Reaction for this we can write down. For example, we have ethylamine CH3CH2 NH2. We can also write as C2H5 NH2 reacts with water. It is a reversible reaction to give C2H5 H1 will come here to the lone pair, so we will get NH3 with a positive charge on nitrogen and OH minus, and this solution will change red litmus to blue. Amines will dissolve, which are basic in nature, will dissolve in mineral acid. For example, you have amine. Second test will be solubility test. So bases like aniline will react with HCl to give C6H5. One H will come here. It will have lone pair of nitrogen to give NH3 with a positive charge plus Cl minus. It is called as anilinium chloride. This is the reaction we need. Whatever statement we are writing, we need to represent this with the reaction. Unless and until you don't do that in your exam, don't expect any marks from the evaluator. This is what you need to remember. So aniline here, we can also write here C2H5 NH2 reacts with HCl. It gives C2H5 NH3 plus Cl minus. No need of plus, it will be included in the structure itself as it is, so it will be called as ethylenium chloride. The third test which we are going to discuss is very important. It is named by a scientist by name Hinsberg, and that is why it is called as Hinsberg test. In this Hinsberg test, we are going to use benzene sulfonyl chloride as our reagent. So benzene sulfonyl chloride means we need to write benzene first. Sulfonyl group is SO2 Cl. This is benzene sulfonyl chloride. The importance of this particular reaction or qualitative test is we can easily identify whether the compound is primary, secondary or tertiary. So Hinsberg is basically for primary, secondary and tertiary amines if you want to separate them. So what happens is when you are going to use benzene sulfonyl chloride, we are going to react this with our amine. This amine is primary amine. This now H and Cl will be removed as minus HCl, which I am going to write above the arrow. What is remaining here is benzene structure, SO2. Then this will bond with the remaining part, that is NHR. NHR. This, because R group is called as alkyl and it is attached to N, it is called as N-alkyl. This particular group is benzene. This is called as sulfo, and this NH is amide group here because of this It is called as sulfonamide. Sulfonamide. So this is insoluble, and if this particular mixture, whatever we are trying to test, contains primary amine, it will react with benzene sulfonyl chloride, and which leads to the removal of HCl to give an alkyl benzene sulfonamide. So that will be insoluble, and we can very well be sure that that particular amine is primary amine. Next step to this will be, in the presence of a base, the particular hydrogen which is here remaining will be removed, so that we will get this H will this particular H will combine with OH to be removed as water, and this Na will form a salt. So the solution what was insoluble now will be made soluble when it is treated with a base to give SO2 as it is, NNR, because hydrogen will be removed as proton, the bond will shift here, so that N will have negative charge and Na will be as a positive charge. So this particular compound is soluble and it is acting as a salt. So very simple step. First step is benzene sulfonyl chloride will react with NH2R, leads to removal of HCl. This gives N-alkyl benzene sulfonamide, which is insoluble. If we have a hydrogen which is there in this insoluble solution, it leads to next step, that is, it is made alkaline, and this leads to formation of a salt which is soluble. So this is the major thing which is going to happen. First, we need to remember, in Hinsberg test, we are going to use benzene sulfonyl chloride. Primary amine gives N-alkyl benzene sulfonamide, which is insoluble. Later it is made alkaline or basic with the help of NaOH to give a soluble salt. This is for primary amine. The same thing if you are going to use, for example, as it is benzene sulfonyl chloride reacts with secondary amine. Secondary amine has two R groups attached. So this H and Cl will combine to give, minus HCl will be removed. This one is SO2 with N, as it is R and R. As you have two R groups present, this particular compound is called as N comma N dialkyl. Previously it was only N alkyl because it has one alkyl. Now because it is having two alkyl group, N comma N dialkyl, as it is benzene sulfonamide, and this is as it is insoluble. This, if made alkaline, will not give any reaction. Why it will not give any reaction? But because this particular compound does not contain any active hydrogen or acidic hydrogen present. So there is no reaction due to no active hydrogen present. So the secondary amine will stop here. So this is how we are going to identify secondary amine, where it will give insoluble solution. The third reaction is if you have benzene sulfonamide with tertiary amine, where all the hydrogens are replaced by R group. So there is no active hydrogen present in the tertiary amine. So the reaction will not proceed forward. So tertiary amine can be separated in the first place itself. So this is how we are going to show the qualitative test for amine. The first is tertiary, sorry, litmus test. followed by solubility test, followed by Hinsberg test, where we are going to use benzene sulfonyl chloride. I'll be preparing short videos one after the other. I advise all the students to please refer to that, make a note of it, and then uh, finish off it unless and until you just want to revise it later on. So this is how I'll stop here. Next topic will be the structure and uses of the compound given in the fifth chapter. With that, we'll complete that chapter totally. After that, we'll start alkyl halide important topics. Almost it's very easy thing. I'll discuss all the things of that particular chapter. Then at the end, I'll explain you what is the difference between E1 and E2 and those things which we are left over. So I know it will be difficult for you, but this is the only way, and this is very simple and easy topics. Only thing is you need to remember what I am telling you now and refer to the notes, as well as you can also refer to the textbook what we are having. And representation of the answer is very important. If you have got doubts in that, you message me. I will make a presentation on that also. Thank you.